there, Ms. Heaton signing in to talk with you about balancing redox reactions that occur in basic or base, high pH solutions. So Ms. Ewald went through how to balance reactions that are happening in acid, but not all redox reactions occur in acidic solution. So we're going to basically be doing the same thing. We're going to go through another example where you balance an acid, because that's how you start these. And then we have 4 new steps. So make sure you get those steps written down and our example written down, and we will dive right into balancing. So the first thing we're going to do is balance as we would normally. So the first thing we want to do is write our 2 half reactions. MnO4 minus turns into MnO2, and Cn minus turns into CnO negative. So now we'll balance everything except for hydrogen and oxygen, and it looks like that's already done. Carbons are balanced, nitrogens are balanced, manganese are balanced. Then we want to balance oxygen by adding H2O. Here there's 4 oxygens. There's only 2 over here, so we'll need to add 2 H2Os on this side. And in our other one, we've got 1 oxygen versus 0, so we'll need 1 H2O on that side. Now we need to balance the hydrogens by adding H+. There's 4 hydrogens on this side, so we'll need 4 H pluses over here. And here we've got 2 hydrogens, so we'll need to put 2 H pluses over here. Remember that H plus would only occur if you had an acid, because acids contain H plus. If you have a base, they're not going to be there in the end, but we'll deal with that in just a minute. Now I want to balance the charge by adding electrons. So let's see. On this side we have 4 positive and then a negative, so that adds up to positive 3. And over here we have 0 charge. So to make those 2 sides equal, we'll need 3 electrons on that side. Let's see, in our second half reaction, this side is 0 and -1, and then this is -1 and positive 2, so that's positive 1. So to make those 2 sides the same, this side needs to go down by 2, so we'll add 2 electrons, so that adds up to -1. Okay, let's get rid of our work here. Now we want to see if our reaction's electrons would cancel out if we added them up. They won't, so we're going to need to multiply our half reactions by a factor, this one by 2 and this one by 3, so that we cancel out our electrons. So this is going to become 6, this will become 8, this will be 2, this will be 2, and this will be 4. And then this one will need to get multiplied by 3, so this will be 3, 3, 3, 6, 6. And now we can add them up. Let's see here. Oh, you know what? I'm going to cancel before I add them up. And it looks like here we have 3 H2Os on the reactant side and 4 on the product side, so that'll become 1 H2O on the product side. And for H pluses, we've got 6 H pluses on the product side and 8 over here, so that'll be 2 H pluses. And our 6 electrons and 6 electrons will cancel. And I believe that's all that's going to cancel. So now we will combine and rewrite that. 2H plus 2MnO4 plus, MnO4 minus. Very important to keep track of your positive and negative signs here. That'll turn into MnO2 and an H2O and 3 CnO negatives. It's not a bad idea at this point to check to make sure that you balanced it correctly in terms of charge and atoms, and I think I'm doing good here. So now we're on to the new part. That was all review. The new part isn't actually that difficult. All we need to do is notice that, oh no, there's acid as this is written. We wouldn't ever have any acid in a base, so what we'll do is we'll add enough OHs, enough base, to cancel out any acid. But just like in math, if you do something to one side, you have to do it to the other as well. So we'll have to add 2 OH minuses to the product side. Remember, hydroxide is a base. So essentially what we're going to do is cancel out our acid and turn it into HOH, or H2O. So this will create 2 H2Os on the reactant side. Now we need to reduce any duplicates. And what we see here is that we've got a water on the product side and 2 waters on the reactant side. So that will reduce. This water will cancel with one of these waters, leaving behind just 1 water. So now, let's rewrite what we have. We have an H2O on the reactant side. We have 2 MnO4 4 minus. We've got 3Cn minus. And that turns into 2 MnO2s. And the H2O is gone. And 3 CnO negatives and 2 OH minuses. Woo! Okay, so let's check our charge, make sure the charges are the same on both sides. So we've got -2 from this and -3 from this, so that's -5 altogether charge on that side. On the product side, we've got 3 negatives and we've got 2 negatives, so that also is -5. So that's a good sign. Then maybe we should check our hydrogens and oxygens to make sure that it's balanced. 2 hydrogens here and 2 hydrogens here, so that's good. Oxygens, we've got 1 and 8, that's 9 oxygens. And then over here we've got 4, 5, 6, 7, 8, 9. 9 oxygens. Okay, so we are balanced. That would be a balanced basic redox reaction. It's kind of a misnomer to call it basic, right? It's pretty advanced. If you feel good about that, great. If you need a little bit more practice, check out the tutorial that's linked right below the screencast. Come to class tomorrow with your questions. We will do the best we can to get you straightened out. Happy balancing.